Hello, my name is Chloe Sanchez Prado and my intended major is biomedical engineering.
Hi, my name is Savannah Folk, and I plan on majoring in mechanical engineering.
Hello, my name is Nicholas McEntcher. My intended major is nuclear engineering.
Hi, I'm Matthew Figaro. My intended major is mechanical engineering.
We started by defining the problem, which was designing, constructing, and testing a concrete canoe. We then looked at the restraints and requirements for this project, which were the dimensions to be 18 by 6 by 5 inches, and it has to be constructed completely of concrete. The concrete must be made of liquid cement and aggregate. It has to have a smooth exterior, a V-shaped bow, stern, and hull cross-section, and it cannot be covered in waterproofing material. It also has to be under a budget of $40. Our design was created on SolidWorks. We split the canoe into multiple cross sections of about 1.5 inches from a top view to get the different layers so we could eventually cut them out in foam pieces. After researching multiple materials, we decided on Portland Type 1 concrete, place sand, crushed packing peanuts, polyfoam board, mesh spackle tape, a bucket, X-Acto knives, glue, stir sticks, and plaster crack. From here, we took our design that we created on SolidWorks and spliced it into multiple layers, printed out those layers, and placed them on the polyfoam board to cut them out with X-Acto knives. We completed our molds by gluing it together. In concrete ratio testing to ensure that we chose the strongest mixture. The main factor that we messed around with was the aggregate proportions. The two types of aggregate that we used were sand and polyfoam or packing peanuts. We made observations based on absorption, buoyancy, and strength of the test pieces. A 1.5 to 1.5 packing peanut to sand ratio was the strongest and most effective mixture. Our first attempt at mixing was really messy. We covered the mold with a plastic beforehand to ensure that it wouldn't stick to our mold. After curing for 48 hours in a solid temperature of 70 degrees Fahrenheit, our canoe slid right out of the mold.
This is canoe number 1, test 1.
Although the water did not seep through the walls and seemed very durable, the canoe did not float and was too heavy. When redesigning our canoe, we went to reshape the mold to be more flat on the bottom, and we also planned on making the sides of the canoe thinner. After redesigning the canoe, we went to mix and pour the concrete again. We used the same idea of support structures with the spackle tape to create that internal structure, but this time we made the canoe just a tad thinner in the walls to lose that extra weight.
The second canoe is flatter on the bottom and is just a little thinner than the other canoe. Still a tad heavy, but let's see how it floats.
So our observations were that the walls are still too thick, and even though there was a more flat bottom, it was still a little too heavy for it to float. This canoe showed a lot more signs of buoyancy because of its lighter mass and new shape, and it was also just as durable as the first one. Based on the 2 tests we did to see if our canoe floated, we obviously did not do too well in the competition, but we did follow all the restraints. So, what were our struggles?
One thing I found challenging about this project was finding times that we were all available and able to meet.
Some things that were really difficult about the project, though, were one, working with people that are so different because you have to find ways to work together, and also the time management. Time management was a big struggle for us, especially with pouring concrete. We needed a lot of time, and trying to fit that all into each other's schedules when they're vastly different was a bit of a struggle for us, but I think we worked it out in the end.
Something that I found a struggle with was being able to cure it correctly. I think next time, if I were to do it differently, I would use a male mold instead of a female mold. That way we can better monitor the depth of the thickness.
What would we do differently? Manage our time better, work together, make our canoe thinner, and monitor the depth as we pour. Advice for incoming students would be to take Fed seriously, to make sure that you have a good group and you work together well, and if not, address those problems from the beginning. I would also suggest to spread the work out and make sure everyone is contributing. That would be the biggest help itself.
Working with people with very diverse talents from different areas, this really allowed us to specialize in different fields and work with each other to produce the best product.